Hello, I'm Santosh, and here I'm going to explain what is solar mobile charging station and how it works. So basically, we will see what different components are used in solar mobile charging station and what is the function of that particular components. So basically, first we will see the explanation of block diagram, then we will see the explanation of circuit diagram. So as you can see here, the block diagram starts with solar module. So obviously, solar mobile charging station will be powered by solar module. So as we all know, the output of solar mobile charging station will be 5 volt because if you see the mobile phone, the charging voltage required for mobile phone is 5 volt. I'm talking about normal mobile phone standard chargers, not the booster charger, right? Standard 5 volt 2 ampere charger. So basically in market, each and every mobile supports 5 volt 2 ampere charger. Fine. So here, as we can see, the output must be 5 volt 2 ampere. So now we will see how it is happening. And in this project, we have implemented IoT platform also. So we will see how it works. So first of all, we have used two 10 volt. Sorry, we have used single 10 volt 15 watt solar module. So as we can see, the input voltage is 10 volt, and the we have source selection circuit here. So basically in this project we have solar input as well as grid supply also. Means we are getting 5 volt in charging input from the solar and as well as 5 volt input from the grid supply. So because so from 230 volt AC to 5 volt we are converting. Fine. So I will start from here TP4056. So if I see this TP4056, this is nothing but the lithium ion battery charger. So as you can see here, in this circuit, we are using 20 Ah 3.7 volt lithium ion battery. So the voltage of this lithium standard state, what we call the standard voltage of this lithium ion battery is 3.7 volt. To charge this 3.7 volt lithium ion battery, we require lithium ion battery charger. So we have to have BMS, that is battery management system. So TP4056 is nothing but lithium ion battery charger, as well as it has protection circuit also. If the battery is fully charged, it will disconnect the battery from the charger, and if the battery is fully discharged, it will disconnect the battery from the load. So in between charger and battery, we are using INA219 current sensor. This is the digital current sensor. Its range is, it can measure voltage, DC voltage as well as DC current. So the range is up to 25 volts, and the current you can measure is around plus minus 3.5 ampere. So the input of this current sensor will be given to node MCU Wi-Fi controller. This node MCU Wi-Fi controller is Wi-Fi as well as microcontroller. So this is nothing but this device is implementing IoT platform in our project. So from this TP4056 lithium ion battery charger, we are charging our lithium ion battery. So this node MC will be connected to Blink app. So what happens in IoT? This node MC will be connected to local Wi-Fi modem. Let's say you have a router, internet router in your home. So in programming, we will put the ID and password of your internet router, and this node MC will be connected to that home router, and then this node MC will be connected to internet through your home router. And by using that internet, this node MC will be connected to Blink app also, which can be installed in your mobile phone. And there you will get the access of this node MC, and you can monitor the voltage and current being transferred into this lithium ion battery. So to operate this node MC Wi-Fi controller, we need 5 volt because this operates on 5 volt. INA219 also operates on 5 volt. So that is why because the TP4056 input requires 5 volt, we are converting 10 volt into 5 volt by using this power supply. By using this power supply, we are converting this 10 volt into 5 volt, and then second, this is the supply 1 which is coming from solar module, and this is the supply 2 which is coming from grid. So in grid we have 230 volt AC, so we have to convert 230 volt AC into 5 volt DC. For this we need rectifier as well as filter. So after 230 volt AC, we will connect one transformer which will bring this 230 volt DC down to 12 volt, sorry, 230 volt AC into 12 volt AC. Then we have to convert that 12 volt AC into 12 volt DC. For that, we will use bridge rectifier W04. That component will convert 230 volt, 12 volt AC into 12 volt DC. Then by using capacitor filter, we will smoothen that to 12 volt DC. Then that 12 volt DC will be converted into 5 volt DC by using this power supply. In circuit diagram, we will see how this power supply works. So this is nothing but 5 volt regulator. It will convert 12 volt into 5 volt. This is how the charging section is working. Same 5 volt we are getting from here, and source selection circuit can be controlled by the node MCU, means from your mobile phone. So if solar is not available, grid supply will be given to battery charging. So if solar is not available, don't worry, your battery will be charged by using grid supply. If you have grid facility, you can apply. If you don't have, no issues, you can keep solar only. So as we all know, the lithium ion battery has 3.7 volt only, but the charging voltage required for mobile is 5 volt. So we have to step up this 3.7 volt into 5 volt. So for that we are using boost converter module. It is MT3086 module, which converts 2 volt to 40 volt. So here we have, means it is adjustable boost converter. We can step up from 2 volt to 40 volt. So here we have 3.7 volt. So we will keep output to 5 volt, so that this 3.7 volt will be boosted to 5 volt, and maximum current it can allow is 2 ampere. And at the output of this boost converter, we have connected USB port to which your mobile phone can be connected. So basically we have total 4 ports which is connected in parallel. So the output of this battery is parallelly given to all 4 charging boost converters, and this boost converter output will be 6 to 5 volt, whatever will be the input, from 3.7 volt to 4.2 volt based on the charging percentage of the battery. And this USB port is used to this USB port is given to connect your mobile phone. Thank you.